Hello, everybody, and welcome. We are glad you're here. This is one of our YouTube videos on drone topics, the heavy lift drone. We have a YouTube channel, and we are happy for you to subscribe to that. I would be glad for you to be there and be a subscriber. This image here, a lot of the work that I do is imagery, image discussions. This is an image of a heavy lift drone, has 6 propellers. This is Gunnison Mountains in Gunnison, Colorado, and our 2 guys are looking up at the drone as it flies by. We always want to add, this is a discussion of an object or set of objects that could be created as real. There are dangers associated with real objects. Any real object could hurt somebody or be a danger. You should always manage and control your real objects so that they are reasonable and safe and are legally allowed. Our advice is do not create any physically real object unless first you have the legal permission to do so, and the way that you will manage it is a way that is legally allowed and reasonable and safe. And now we're in SketchUp, a drawing program. This is a representation of a person. This is 6 feet. This person, this lady or this guy is 6 feet tall and has the proportions of a human. This allows you to see the scale of the robot. This is 65 gallons of water, is 500 pounds. This particular drone is set to have a 500-pound payload. Up in the front of the drone, it has wings, it has 6 propellers. It sits on its legs, and when it takes off, it folds its legs up. So it has gone up in the air, it's folded its legs up, and now they're completely folded up, and it has rotated itself around so that it's now flying this way. And instead of the propellers lifting it up in the air, once it rolls itself over and is going this way, the air flowing over the wings provides lift to keep it in the air. And we have a specific discussion point here. This is our desk, the computer monitor. This is a little box. This box has 6 dials on it. And the mannequin is sitting here and can reach over and grab onto these 6 dials if he or she wants to. And each of these dials, each one of them, controls one of the propellers of the drone. And we'll go back to that other diagram and we'll say, all right, here you are. Here's your control panel. Here's your 6 dials. And what's going to happen is we're going to fire this drone up and start running these motors, and you are in charge of these 6 dials. Each one of these dials controls one of these propellers. And we want you to get the drone on up into the air. We'll take care of folding up the legs for you. You get it up into the air. Get it flying. Here you are again with yourself in front of this box with the 6 dials. And we have a math discussion here where we demonstrated that this drone has the ability to bring itself into what we call fixed wing flying, where it was being pulled straight up into the air by its propellers, and it started to add power to these propellers and back these off, so that would tend to turn it. And as it continues to back the power down here and increase the power there, it will roll itself over. And what we were demonstrating with this power discussion was what's going to happen. And what will happen is it will lose 240 feet of altitude, and in a span of 4 seconds, it will be flying along at 70 miles per hour, which is, here we have the 500 pounds of weight in there, and this is a drone that's being powered by a jet engine. But it has enough forward velocity to generate enough lift to hold itself up, so it doesn't need its propellers. And we again put this little guy here, this little lady or this little guy here, and say, all we want you to do is run these 3 dials and get those propellers to do that, so that this drone flies along and doesn't get into trouble. And the interesting point about flying drones and getting them to go up in the air and behave themselves with a human being turning dials that control the propellers exactly. The interesting thing that was a great surprise to a lot of people is that human beings are not capable of doing this. It won't work. The calculations are too complicated. They have to be done too quickly. It's a little bit counterintuitive what should be done. Human beings cannot do those calculations and move those dials with enough precision and speed to get a drone up in the air and stable. It can't be done. It's a big surprise. And so we'll take the picture that we showed you earlier, and the 6 dials are here, and we're not really going to be doing anything with them. We need to talk about how drones actually really fly. And this is a block diagram. This is the body of the drone. It has tilt sensors and other sensors on it that establish what its aeronautical configuration is with respect to it flying in the air. The value from this obtaining of sensory information is sent down to the central processing unit. The central processing unit then talks to the central processing unit area that has flight control algorithms that tell the central processing unit what these sensory values mean or what the importance of them is. And the central processing unit also has separate areas where there's a safety section that evaluates what's going on with the drone and makes safety recommendations of what should be done to try to keep the drone safe from lighting on fire and crashing, etc. There's another set of algorithms that look at what is the behavior of the drone and what is the behavior that you would like for the drone, and it makes recommendations of how the central processing unit can change around what's going on to obtain the behavior from the drone that is wanted. And these 2 systems send their recommendations back and forth to the central processing unit algorithm area. That then sends final conclusions to the central processing unit. The central processing unit then, here is the power to the motors. The central processing unit, on the basis of all these decisions, sends advice or commands to the motor, telling the motor how fast it wants it to spin. So instead of 1,000 RPM, it might ask it to spin at 973 RPM, and it may ask the other motor to spin at 1,002 RPM. This effect occurs, it changes the values of these sensors. These sensors create another package of information which they send to the central processing unit, and the central processing unit begins this loop again. And the central processing unit is basically handing control of the drone to the safety system to see what it wants to do, and then handing control of the drone to the behavior system to see what it wants to do. These go back and forth between each other maybe 10 times a second, and this whole loop occurs maybe 10 or 20 times per second. And once they allowed that, you'll notice, by the way, I've never said a thing about this human being over here. Once that loop was allowed to function and go around and around and around like this 10 times a second, 100 times a second, they discovered that they had a stable drone. It really could go up in the air and fly, and it wouldn't crash. And where the human being comes into this discussion is the human being. All right, you'll notice that we call this the human to CPU, also CPU to human interface device. So you just forget about these dials. The human being goes over here to this keyboard or control panel or interface, and the human being says to the CPU, hey, this is what I would like to do. And the CPU says to the human, thank you, I will check that out. If I can figure out a way to do that, I will do it. But the CPU also has a safety CPU and a behavior CPU algorithm area, and it takes what the human being says and says, I'll do what I can to do that. But what is actually controlling the drone is the computer, not the human being. This is very fundamental to understand. It was quite a surprise. So anytime you see a drone that's, quote, under the control of a human, it is not. The drone is under the control of the central processing unit, because that is the only thing that can successfully control a drone. The input from the human being is simply a request to the drone for what the human being would like it to do. And this whole lecture series is going to be about this interface, exactly what that interface should look like. Up here, of course, now you'll notice I have over here electric, because it's all electric. And the reason why the drones have been electric is because this loop at this speed, once every 1/10 of a second, can be done with electric motors. You get a problem with scaling up of electric motors, and I want to try to see if we could do this with hydraulic motors, because with a scale concept, you can get very, very big hydraulic motors that really could exist right now, today. And really, really big electric motors that have really, really big batteries that have enough weight to be really big. They wind up being electric systems that can't go up in a heavy lift drone because they're too heavy. But that's another topic. What we're going to talk about right now is just the concept of, okay, we have a drone, it's under the control of the computer, we would like a human being to be a part of this, and what would that interface look like? The last thing we should mention on this interface is I want to design a drone that's a military drone. I want this drone to be a drone where people who are going to be hurt or are going to not survive, who are in the battle area saying, it's over for me, I can't believe it, and then the drone shows up and saves them. It arrives, it does whatever it needs to do to get them fixed and saved and well, and it picks them up and it leaves. And so this is a military drone, and this is a drone that is making people well and healthy. And so I don't care what the drone looks like. I don't care if it has pastel colors and it looks like a frozen drop of water. This is not a drone that's made for a rich person who wants to go from the airport to downtown and feels like they just don't want to sit in a taxi cab and be on a road with all the other people. They just don't want to do that. They want to bypass that. I'm not talking about that. I'm talking about a military drone where its purpose is to save people. And so the control panel that I'm talking about is the control panel for a specific drone concept of the human being wants the drone to do a military job. And we really do not want to have a drone that you have to have 3, 4, 5 years of pilot experience and flying aircraft to be a fully certified and experienced pilot in order to be in this drone. We don't want that, because remember, the drone is completely capable of flying itself. And if we convert this into a requirement that they have to be totally trained and fully qualified pilots, you're going to wind up with a situation where there aren't any drones that are available to help anybody because there's nobody to fly them. So I want to talk about and discuss a interface here where just regular people can get this drone to do a military activity. And so that's our first video on this topic.